Hi everyone, my name's Peter Shields and on behalf of AirMet Scientific, I'm pleased to welcome you to today's webinar. We're very fortunate to have Volker Brands, the Regional Sales Manager from NADA Safety Test Solutions in Germany, joining us today to present on radiation and personal safety monitoring for 5G future. With huge public interest around the safety of the rapidly growing 5G network in Australia and other countries, we wanted to get you some background on the potential hazards and how to ensure your safety when working in environments with potentially high levels of radiation. So I'll now hand over to Volker, who's kindly agreed to present on this topic today in the early morning in Germany, so we could host the webinar during Australian business hours.
Thanks, Peter, for the brief introduction. For the coming hour or so, I want to focus on a special 5G aspect that is regarding the safety of humans during working on towers and base station sites. My name is Volker Brands. As Peter already introduced me, I'm the regional manager, being responsible also for your region. Regional sales manager from NADA Safety Test Solutions here in Germany. We are situated a little bit south of Stuttgart. So let us directly jump into the presentation. I understood at the end we have a question and answer session. The session is split up into let me start with basic notes on the safety hazards which may arise in your working environment. Then I want to introduce you the latest product for personal safety, which is mainly the revamped good old Redman, which we are already selling since a quarter of a century. And then finally, I have a few pictures and also a few video showing a little bit the instrument in action. So the content will be a brief recap on the EMF effects on humans. An introduction to personal radiation monitoring, discussing new Redman tools, functions, and features, an overview of set radiation exposure limits and how the Redman tool is optimized for these standards, how human body affects radiation readings, so how the results may be affected if there is incorrect, improper use of handling of the Redman, how we counter measures to those body effects. Then some applications, its capacity to protect workers in public. In the annex, I have a few video slides, pictures, and also a little comparison between the actual current products we are offering in that respect, the Redman 2 and also the NADA Alert S3, which is another alternative, though being more used in the defense industry, especially for its capability of even alarming for signals up to 100 gigahertz and using a slightly different test technique, which is called thermocouple probes, which have the advantage of inherently correctly give right results for highly pulse signals, namely radar signals. An instrument which is a little bit more in the as the capacity of measuring very strong fields and, as I already said, pulsed fields. So let's start with going back. What are the electromagnetic field effects on humans? So we focus today on the radio frequency effects. And these effects which are being described are the so-called thermal effects. So we will not discuss about the stimulus effect. So induced currents, induced voltages for the extremely low frequency. That will not be the topic of the lecture of today. So we focus only on the thermal effects. So and these thermal effects are basically body heating. So the Redman is designed and is focusing on the electrical and magnetical fields and the effect with respect to body heating. RF radiation heats the body because water molecules begin to oscillate. So the heating is produced by the so-called friction losses, and this energy is being absorbed by the body, and depending on the dielectric properties of the tissue. and the result is a partial or full body heating, and this is being described by the absorbed power in watts per kg of body weight, which is also called the SAR value, which you probably also know, which is the technical spec also of each and any mobile cellular phone and modem, not only of the radiating part of the BTSs where we focus today on. The effect is a little bit different. So the focus is where you see the triple plus symbols, where there is a high absorption rate. So most sensitives are the lens of the eye, and these are also the most typical injuries which may happen. And this is really reported still from time to time that this is happening. That workers get effects on in the first instance of temporary blindness, and of course, if you stay too long in a RF field, then this might, in the worst case, become a permanent thing, that there's permanent blindness. This being reported still from a few riggers in Europe. I recall a few cases over the last years. But that is also happening in wartime. So we also have a few instances from the last war we had in Europe, the Yugoslavian wars in the Balkan mountains, that people in the winter were warming themselves up in front of radar beams, and also in that environment, it happens from time to time that you have this so-called clouding of lenses. Teeth fillings is another critical part of the body. Of course, implants, but with implants we need to differentiate into two cases. One is that active implants being affected by non-sufficient or too high radiation in combination with too sensitive or ingress into active implants. So here we more talk about EMC effects, electromagnetic compatibility effects, rather than EMF effects. But with metallic, so passive implants, there is again the heating effect, kneecaps. So basically, it's the issue with all the parts of the body where the temperature cannot quickly and easily being distributed, so that you have a high dissipation and that you have a local that the heat remains locally in parts of the body. And so the combination of high absorption and not fast bringing this heat into other parts of the bodies, that is the critical combination, which may lead to negative effects. Let's have a look at the body's absorption curve as a function of frequency. So the resonance range is well within 30 megahertz and 300 megahertz. Then you have the hotspot range, and in the gigahertz, so the higher the frequency basically is the goal, the rule of thumb. The less deep the RF will go into your body, and you will have more effects on the surface. So with the millimeter waves, for example, it's mainly then burns on the skin of the body, and the lower the frequency is, the more deep the thermal effects will affect your bodies. So basically, we talk about resonance, we talk about body parts, limbs, and so on, which act as lossy antennas, and will pick up the signals. Generally, we need to think of heating, reflexes, influence on cell communication, cell growth, all this being reported, influence on hormone balance, psyche, effect on cardiac pacemakers. We had that on passive, non-passive implants, weakening of immune system, risk of cancer, lens clouding. So that is all discussed, but ultimately only the short-term effects are being proven, are being reported by United Nations, by the sub-department which is called WHO, World Health Organization, and then especially what we put here on the bottom of the slide, the ICNIRP, the International Committee for Non-Ionizing Radiation Protection, which is providing to us standards and limit curves to deal with these short-term effects. Again, heating, reflexes, effects on cardiac pacemakers, and most commonly the lens clouding with the effects of temporarily or permanent blindness in the worst case. So this risk, of course, with all people which are working in the infrastructure, or any transmitter stations. So we see point-to-point microwave radio links, satellite communication, radar, and then of course, last but not least, the BTS, the base transceiver station towers. So important is to educate workers about the risk from electromagnetic fields, how to detect adverse health effects of exposure, how to report them, training to have a safe working practice to minimize the risk, provision of information about the site, about the radiation sources available there. One possibility is also to use protective clothing, extremely high exposure environment, and last but not least, the topic of today, use a personal monitor to warn against high radiation. Why should someone use a personal monitor? It's not always possible to ensure that the exposure of workers is below the occupation exposure limit values. The electromagnetic radiation cannot be felt or heard or tasted. If you feel the consequence, it's usually too late. So first effects of temporarily blindness, for example. And the personal monitor gives us a way to perceive the RF radiation, to display them, to measure them, and which allows us to get out of the danger zone well in time. The personal monitor will also have an RF detection mode. The frequency pitch is altering with the field strength, so you can allow really for a quick check if antennas are really turned off. This is increasing safety. That is a special feature and function of the so-called Redman 2 XT model, so the extended version of the model, which has a wider frequency range, so which is also covering the upcoming millimeter waves for the higher frequency band in 5G. The personal monitor also displays the level of exposure. This usually allows the radiation source to be localized and the hazard to be better assessed. And last but not least, easy to use, should be easy to use, and it should belong to every set of personal protective equipment. So the Redman 2, around a quarter of a century back, almost 30 years back, where we still were under the brand of Wandel and Goltermann. The first Redman was designed. Now, after 25 years, we decided to redesign it. And by that, of course, we had the chance to improve a few things. So what you see on this display is the sensitivity has been improved. So we added an LED, which is even showing 5% of power density. Percentage is always an integration over the filtered curve in line with the standard, for example, the IC and IRP standard for occupational environment. So on the one hand, NADA extended the range. So the XT model is covering the frequency up to 60 gigahertz. So that is well covering all microwave radio links. It's covering well the upcoming millimeter wavelength range of 5G. So that's the reason why we said it is 5G ready. And a couple of new features I want to focus in. The first one is a built-in sensor test. I know that many of our users still use an emitter source to make the ultimate test of that the personal monitor is working correctly. But we digged into the history of our repair, service, and calibration sites, and found out that The only few cases and instances where you have where errors or malfunctions have been reported are with the diodes. So you probably know that this kind of personal monitor consists of six antennas, 3 dipole diode systems, and 3 dipole coil systems. So what we are testing is the RSS of the RMS value, so the root mean square value, and we do a root sum of square of all the 3 planes, x, y, z, so the different planes of the incident possible waves. If the instrument is fallen down and there is a mechanical failure, then the connections on the printed circuit board may get opened in the worst case by a crack, and then these diodes or the connection will be in open, and that has been checked during the self-test. So when you switch on the instrument, it will check that all the 6 connections to these 6 antennas are being low ohmic. If they are high ohmic and if they are open, then there will be an alarm and the instrument will not work. The other instant may happen that you carry or that you expose the instrument to excessive radiation. Excessive radiation means above the destruction limit, which is well described in the data sheet. So if you are in fields which are above the destruction limit, then there is a risk that the diodes are burning because of too high signals, and be aware that this is also possible if the instrument, or that will also happen if the instrument is not switched on. Yeah, it has nothing to do if the instrument is switched on or off. Yeah, these diodes might burn then in the worst case if it's above destruction limit, and then again if the diode is burned, you will have an open, and again this open connection is being checked during the boot phase of the instrument. So we would expect that more than 99% of all these instances will be covered by this internal check. But of course, you can still carry on with your good old method that you use whatever garage door opener or walkie-talkie or whatever emitter, and do a real functional test over the air. The display is same as with the elder models. We have this patented shaping, which displays the result directly in percentage of limit value, which is always a power density, so it's not the field strength, but the square out of that, so it's the power density. You need no conversions, no settings. It's directly according to ICNIRP, to the in Europe, the European Workers Directive. In the US, the FCC shaping, or in Canada, the Safety Code 6, so which are the major limit curves which we find globally. We increase the loudness of the alarm, so you hardly can miss any alarm, but we know that customers are very often in very noisy environment. That means on the roofs of the skyscrapers, we typically have the towers, you have the AC conditioners, so you have probably the noise from the roads, which are reflected up to the top of the buildings. So we thought it's a good idea to increase the loudness of the alarms. But secondly, we also increase the angle of the red LED light display. It's 270 degrees, so you can really see it from an extremely wide angle if you look on the top of the instrument. And last but not least, now also including a vibration alarm. So you have these 3 alarms if the limit is being exceeded, and then by the law or by the standards, you still have 6 minutes times to get out of the radiation hazard zone if it indicates the 100%, because that is based on 100%. On a 6 minute integration time, so where you have the maximum absorption of energy and the maximum heating effect. Thirdly, also the frequency range has been extended, so we have a lower cost version, the Redman 2 LT, the light version, which covers the frequency range from 50 megahertz to 8 gigahertz, and being also calibrated for that. And then to make it 5G ready, we also offer the extended version, the Redman 2 XT, which is covering all along the frequency range from 900 kilohertz up to 60 gigahertz. As I already indicated, both the electrical field and the magnetic field is being checked. That is in line with the standards. And other differences are not only the frequency range, but also the data logger, which is extended in the extended version. So instead of around 3,000 events, it will log 100,000 events, signal detection through mean square. And as a fourth differentiator, the XT version also allows to have a shorter integration time of 30 milliseconds. This is used for two cases. On the one hand, if you have in the vicinity also radar equipment, then you get an earlier alarming as per the standards. And secondly, we have also integrated a so-called RF detection mode, which is also working with a 30 millisecond integration time, so that you can really locate the source, the emitter, and the antenna segment with the RF detection mode. For the sake of time, we already have used half of the time. I will speed up a little bit, but anyhow, you will get a copy of each and any slide provided by AirMed. So the detection modes which we offer with the XT model in the new Redman is the normal detection mode or the pulse detection mode with a faster, shorter integration time. Instead of 1 second, you can select 30 milliseconds, so that you are well being alarmed fast enough if there is any pulsed signal like radar. Protection of course also covers people which are not so much involved in, which are not technicians or engineers. Could be also instruction people or painter people or visitors. For those, we also offer an LT version for the more sensitive general public limits. With the detection mode, you have an easy localization of leakages in waveguides, coaxial screw connectors. Check if antennas or antenna segments are switched on or off. And with this tone search, you can also quickly detect any leaks by this varying pitch of tone. I've prepared a little video which is easily presenting this mode. We also expanded the hours of operation, which is now 800 hours. So basically, you don't need to charge the accumulators more than 3 times per year, and you have covered the normal working hours of whatever 8 hours per day. It's rechargeable via the USB port, so it's just a standard USB-C interface, which you all know from your mobile or smartphones. The instrument is protected or is rated with ingress protection 665, so it's dust tight, and it also can cope with water jets. A little comparison about the two available models we have today on the market: the Redman 2 and the NADAlert S3. So all of these models more or less presenting alarms. What I want to show here is the optical alarm, which is being visible by the Redman 2 and the NADAlert. Yeah. So by wearing it at your body, you can look from the top by looking down to the alarm sensors. You see with the Redman and the NADAlert, and only with these two models, if we compare them to the other models being available on the market, only these two models are really facing the display and or the LED presentation to your face if you would use them in the normal way. In addition to that, the Redman, like the old world, the incumbent version, the Redman 1, comes with an integrated absorber, which is avoid over and underestimations. The human body acts like a reflector to electric fields, so you don't want to have either or, either an overestimation nor an underestimation. And any electric field probe worn close to the body, like a personal monitor, is affected by those reflections if no countermeasures have been taken. These reflections can cause strong over and underestimation. If the incident field is 100 degrees out of phase of the reflected field, the value can, in the worst case, being completely cancelled out. So an addition of waves with a complementary or the 180 degrees changed phase, or if it's in phase, the reflected field will double the value. So you neither want to have plus or minus 100% measurement uncertainty. So the measurement results from units which are worn on the body without absorber material have a very high likeliness that they are not accurate. So in the holder there is foam, which is like the material which you know from EMC shielded rooms. It is absorbing. This is absorbing the body back reflection, and hence you will get correct readings if you use that on the body. In contradiction to that, if you take it out of the mounting adapter, then you have the full isotropic. Isotropic means test results which are not affected by the direction. You get a three-dimensional isotropic correct reading if you take the instrument out of the mounting adapter. So these are the two models, and the NADA alert and the Redman, with the difference that the NADA alert is using a thermocouple array and can produce true RMS values even up to 100 gigahertz, and it's mainly usable for strong radar fields which are typical in defense environment. The downside or the limitation of the NADA alert is a lower dynamical range. Yeah, so inherently the technology of using dipole diodes and coil diode system is a much higher dynamical range. And the downside of that instrument is also that it has a lower sensitivity. So, for example, we don't offer general public models here. We only offer the models with the higher limit curves for occupational safety. So both have inherently built in the limit curves. So the test results you get is always an integration over the whole frequency range of the power density, with a correction according to the frequency dependent limit curves, for example, of IC and IRP. So you have no risk of misunderstanding or misreading, and you always have by that a maximum of safety by simple presentation of values in percentage of the standard. PC software is available. Those of you who are already users of NBM, that is based on our broadband NADA broadband meter software. It's a full database where you have access to all the results, which you can upload via USB to your PC, and can set up different averaging methods and so on. It's also good for a functional test, because you also have a real-time measurement function here, so that you see the curves in real time of the 3 magnetic sensors and the 3 electric sensors separately. So you can check the functionality also of the probe systems divided by electric and magnetic fields. Okay, I don't want to go too much into details. You find that all on our homepage in the data sheet of the Redman version, the respective version, the light version, the LT, and the extended version, the XT, as well as the NADA alert instrument. So they all offer optical, acoustical, and vibration alarm indication. And Redman offers isotropic measurement. If you take it out of the holder, it will take into consideration the effects of body reflection. If you wear it correctly at the body, the sensors are dipole diodes and dipole coils. In the NAD alert case, it is dipole diodes for the lower frequency, and roughly above 2 gigahertz, the thermocouple principle is used. Okay, before we come to question and answer sections, I just want to show you a few pictures and a brief video. So what you see here is a recent measurement I've done in Scandinavia. It's a Huawei 5G BTS and antenna. Most likely that, like a lot of installations, the traffic is not full load. That's the reason why you only see 5 to 10% of radiation, even in front of the antenna. So that was a 3.7 gigahertz 5G Huawei installation, where we probably just measured the broadcast signal and not so much of traffic. Furthermore, a quick video showing you the sensor fail test if you switch on the instrument. So if there is a failure, the instrument will not measure. It will provide constant alarms. All LEDs are flashing, and it's impossible then to operate the unit, because it's just not further booting and not starting. So you can be 100% secure if there's a fail in the instrument, a failure in the instrument in these 6 sensors, if there is an open circuit. Contrary to that, a successful booting process looks like that. You get a quick functional test that all the LEDs are working. Then you see the battery test. It's now 100%. Battery is 100% full. And of course the unit is working if there is any RF field. Max hold is another interesting function. So especially if you put it on a long rod and you want to measure antennas in a distance. If there is nothing stored, then you just see these LEDs running from top to the bottom. But after it has detected a signal, then you can always just press on so it's a complete one key button operation. You just press once on the key, and then here in that case the 50% field detection is being stored forever. Last but not least, I want to show you this quite unique RF detection mode. Excuse me. So you see, in that case, the instrument is set to the pulse mode. So you see in the XT model on the bottom in the center, the red LED, which shows that the integration time is now 30 times faster. So instead of 1 second, the integration time is now reduced to 3 milliseconds. That is good for radars, but of course that's also good if you use the RF detection mode, that it's immediately showing presenting with this frequency pitch. It's directly presenting in real time an indication of an RF emitter, and you can easily locate it where it is in X and Y direction. Okay, that's all for the moment. Now I would like to hand over to Peter to moderate the question and answer session.
Firstly, are there plans of calibrating in Australia?
That's a question for you or for me?
Yeah, well, I suppose it's for you. Not in the short term. We have looked into it before, but yeah, that could be possible in future. The calibration frequency, I imagine, is the same as the Redman, so that would be every 3 years.
Mhm.
When will the Redman 2XT model be available? And I can answer that one as well, because Volker told me earlier that the first ones will be shipping sometime in July. So yeah, probably July, August. I believe that there's orders for quite a number already. So if you haven't got one on order at the moment, it might not be July, but perhaps August, September. I've got another one here, Volker, you might be able to answer. Hi. Have there been any other 5G field tests other than the brief one in Sweden?
Yes, yeah. So there have been a few, not only in Scandinavia, but also at your lovely Gold Coast. We did a couple of measurements in the last month. Is that correct? May, yeah, in middle of May, there have been quite some extensive tests at the Gold Coast area mainly with Telstra, if I remember correctly. And also these tests, there have been also some benchmarking tests with the older Redman, and despite of the fact that the new Redman is a little bit more sensitive, so it already starts with detection of 5% of IGNIR, it behaved in practice. It behaved identical to the old Redman, and was also reconfirming and verifying that the design is being made just in line what we have done for the last 30 years with the former version of the Redman. Currently, in instruments, the first working prototypes instrument are shipping to basically all places in the world. To the manufacturers, to the vendors, to the operators, no matter if it's in China with Huawei, or I visited personally Ericsson 2 weeks back. I visited some operators in Scandinavia like Telia in Norway, and all the tests which we made so far give a 100% reconfirmation that the design is being as per the specifications.
Yeah. Thanks, Volker. Another question: when will the Redman 2XT operating manual and software be available?
Yeah, as we speak, the operation manual is just being translated now into English. So the German is already there. So we finalized that. So it's just a matter of translation. I think it will be online, not in weeks, but probably in days. On the sales extranet, that means that AirMed will have very soon access to the operation manual. Yeah. Then of course we are happy that you distribute it to interested customers. Yeah.
Yes, I'll pass that on as soon as it's available. Another question: are other countries more advanced with 5G, and are there any significant exposure threats from those with experience?
No, from my experience, no. But I need to restrict this assessment a little bit to the fact that there's not so much beamforming around so far. So most of the trials, the broadcast beams and the traffic beams are still same. So there has not been made so much of tests with the beamforming. So that would create in the worst case a little bit higher exposure than what we had in the past. But as I already said, that most of the systems I've seen so far, the broadcast beams and the traffic beams are still same. So there is not a lot of beam forming around, and there is not a lot of traffic so far around. But also the measurements from Telstra, where there have been quite real world scenarios have been made. So with, if I remember correctly, in the order of 50 enabled, up to 50 enabled systems working in parallel. The exposure rate with these systems currently being placed is not showing any significant exposure over or more than what we know from past 2G, 3G, 4G systems.
Yeah. I think we've got a comment here from Graham down from Telstra. Just to add to that, I suppose that the Telstra Gold Coast measurement showed 5G levels well below 4G. The base stations don't activate full power unless necessary. What's the battery working time under full load?
The operation time is 800 hours.
Yeah.
So that is 100 working days, a quarter of a year. So again, what I showed in the slides, minimum 3, maximum 4 recharging cycles per year is sufficient, so that you can run that Redman 2 almost continuously over a quarter of a year.
Yeah. Okay.
Based on 8 hours, based on 8 hours working day. Yeah.
Yeah. Okay. And another question, Volker. Will NADA be publishing any application notes for 5G measurements using NBN and SRM?
Yeah. First of all, we just finished the first 5G presentation on the SRM, which we already discussed today, Peter. That could be very likely the next webinar in 4 to 6 weeks or so, focusing on selective measurement in frequency domain, measurement in time domain of the 5G signal with a selective radiation meter with the SRM. So, and that could be, of course, also a basis then for a white paper or application note coming up later this year. That's actually a good idea there.
Okay, thanks very much, Volker. That looks to be the conclusion of the questions. So I think thanks everyone for attending today. I'm sure you found it informative and interesting. If you've got any further questions on the NADA product range or anything that was discussed today, please feel free to contact any of your AirMet representatives. Finally, thanks, Volker, for your time today. Very informative and interesting presentation, and I'm looking forward to the future webinars with you. So thank you very much.
Thanks for arranging, Peter, and thanks to the audience. Thanks and bye.